Hi, my name is Mats Irmark. I work at SKF Group as a cloud and infrastructure architect. SKF is the world's largest and most well-known bearing manufacturer. We supply to over 40 industries globally and have 100 plus factories across the world. I'm going to tell you about and show some of the cool stuff that we have been doing for the last 12 months. A little over a year ago, we started a big digitalization journey with the goal of building up a super modern hybrid cloud environment. As of today, we've set most of the standards on how we want to do this. We built this upon the latest and greatest of the Microsoft Azure hybrid stack. Of course, the Azure Cloud. And to allow compute at the edge, we've been early adopters of the Azure Stack HCI and the Azure Stack Edge. We have had focus on managed services, AKS in Azure and AKS using the Azure Stack HCI. Database offerings like Arc Data Services and SQL Edge are core components in our platform. And we're also using the Azure API management for the governance of APIs. We made it as easy to run a Hello World container in the cloud as it is to run a mission-critical containerized application that controls how and when our bearings are produced. Moving an application from a dev state to production is no more work than adding a few lines of code or a config into a Git repository and pass the necessary test or approvals on the way. We're utilizing the latest technology, frameworks and ways of working. Azure DevOps, Terraform for infrastructure, JSONnet and Helm for configuring containerized applications. GitOps as the workflow to allow increased productivity, visibility and security. Argo CD as the GitOps operator, managing deployments to all of our 100 plus factories. The central team here at SKF, or as we call it, the central or global factory, set up and monitor Kubernetes clusters belonging to each factory in the cloud and on the edge. We provide the compute and components needed before a cluster is production ready. On top of that, we allow developers to deploy their apps via GitOps and run them in a secure way. I'll soon give you a short insight into how we deploy the Azure API management local gateways to production in 2 factories. And also have a look at our big Terraform repository, which holds most of our cloud infrastructure. Now I'm going to show you a real-world example of how we deploy the local gateways for the API management service to our factories. The scenario is that we have an API management services running in the cloud. We have set up local gateways for the Swedish, the Austrian and the Italian factory. In this demo, I will deploy the API management local gateways instances to the Swedish and the Italian factory. We're doing this the GitOps way. We're using Argo CD, which fetches its manifests from repositories in Azure DevOps. So let's jump into the code. We have a repository called Kubernetes Cluster Configuration here. This repository contains all the configuration for all our platform components for all our clusters across SKF. Under the clusters folder, we have a list, which will be pretty long, of clusters that we manage. And under each and every cluster here, we have folders for the platform components. Many of these folders are automatically created, so it's not a copy-paste job for us. If we go to the API management folder here, we can see that we have a few lines of code. We're using JSONnet to generate the manifests. If we run this JSONnet file, it will generate manifests for us. We can also do it with kubectl to get them in YAML format. This little piece of code is calling some central code under libs apim, and that code looks like this. JSONnet looks very much like JSON with some programmatic things that you can do with it, like ifs and buts and using variables and merge strings, etc. So this is the code that we're using to generate the manifest, we just pass a few different values depending on which factory it is. Let's jump over to Argo CD now. Argo CD is the GitOps operator, and this is an application in Argo CD. And we have said here that the target for this deployment is the ASE, Azure Stack Edge Kubernetes cluster in the Italian factory. And the manifests for it is in a Git repository in this path. And we can see here that Argo CD has picked up that there is a config map, there is a service, there is a deployment, and there is an external secret specified there. External secret is a component that we use to be able to put secret values in Azure Key Vault and use them inside our Kubernetes clusters. It's a solution that works equally both when you are on the edge and in Azure. We have the same setup here for an AKS cluster running on Azure Stack HCI in the Swedish factory in Gothenburg. So let's click sync here for both these applications. We will see shortly here in the Azure portal that these nodes that starts up in these different factory reports into the central instance in the cloud, that they are alive and are ready to accept connections, and they will fetch their configuration from the central instance in the cloud. And we can see here that they have just reported in that they are up and running. So that was a real world example of how we deployed API management local gateways to one factory in Gothenburg, Sweden, and another one to one of our Italian factories. Now let's showcase how we can make updates on a global level here. If we go to our code base for these manifests for API management, and we change here that the variable image is this one, 1.2.1 instead of 1.2.0. We do git status, git add, git commit. Now I'm doing a direct push to master here. This you can do in many different ways. The most common way to do it is via pull request, and if we're doing this outside of the demo, we do of course do it with a pull request that is being reviewed by the right team. So what's in Git has changed now. The desired state of our API management local gateways has changed. And if we do a refresh in Argo CD, we can see that Argo CD wants to update this from 1.2.0 to 1.2.1. And we can do sync here. And we can see here that a new pod spins up and the old one, it was just removed there. Same here. And we can see in the Azure portal here that the node, it's a new node with a new version reporting in. And same for the other factory. Yeah, that was everything I wanted to show about how we deploy and manage API management local gateways using Argo CD as the GitOps operator, repositories in Azure DevOps, and managing the actual configuration for API management service. This second demo will be a short code introduction to our main Terraform code repository. So, we prefer to use Terraform for managing infrastructure. It follows the GitOps workflow, and it's a really powerful tool to manage infrastructure at scale. We have this repository called infrastructure in Azure DevOps. Under the folder digital manufacturing, we have one subfolder per region. We have East US, West Europe, and work is ongoing right now to set up the first factory in Southeast Asia too. If we take a look under each region here, we can see that we have added the factories that has been enrolled to this new way of working with infrastructure. Under each and every factory, we have subfolders for each environment, dev and prod. And for each environment, we also have subfolders for the different Terraform workspaces that we have. We prefer to keep the Terraform code separate into smaller pieces to allow, basically it's easier to work with smaller parts than one big Terraform monolith. To each and every workspace, we also have pipelines set up. So for each factory here, we have pipelines that triggers when you want to make changes. Let's take a look here at a pull request that happened some time ago. We onboarded a new site in Spain to this repository, and when working on these changes here, we can see that pipelines for the different Terraform workspaces ran. And for the pull request to be approved, Terraform plan must be able to run, and then when the pull request is approved and the code hits master, the pipeline triggers again in a different mode, and it will run Terraform apply and actually build all the infrastructure. So if we go back to this repository, the Terraform code in this repository describes for all our regions and all our factories the current state of all the infrastructure in Azure and some on the edge too. It also allows for people working with different factories to make pull requests to update the infrastructure. It allows for a central team to review the changes to make sure that everything is correct. Since we have all the factories in this single repository, it also allows for knowledge transfer between factories. If a team at one factory has created some infrastructure, it will be visible to all other factories, and they can use the same solution. Yeah, I think that was everything. Short introduction to our Terraform repository. Thank you.